Welcome to Electron Line, and now we're going to take a look at angular measure or angular size. In astronomy, it is very difficult to figure out how far things are, and we'll talk a lot about that in our future videos. But one thing we can do is measure the angular size of objects. For example, let's say that we are looking at the moon and we're wondering, well, how big does the moon look? And you're looking at, oh, it looks about that big. But really, the way to measure it is to say, okay, if I draw a line from where I'm looking to the top of the moon, and then I draw a line from where I'm looking to the bottom of the moon, notice that this then makes up an angle. Let's call it angle theta. And so we measure things in astronomy, we measure things in the universe by how big they appear angle-wise. How much of an angle does this subtend? And for the moon, it's about 1/2 a degree. So 0.5 degrees would be the angular size of the moon. Now, how big is the sun? Well, we know the sun is much, much bigger than the moon, but since the sun is also much farther away than the moon, it turns out in the sky they look about the same size. That's why when there's a solar eclipse, the moon travels in front of the sun. The moon disk, the size of the disk, just barely blocks this disk of the sun. And when we have a solar eclipse, that's because the disk of the moon just passes past the disk of the sun, and since they're about the same size, the moon's disk covers up the sun completely. And so it turns out the angular size of the sun is roughly about the same size as the angular size of the moon, and it's about 1/2 degree. So they have the same angular size, even though, of course, knowing that the sun is much bigger than the moon. Let's say we look at a constellation. Here's the part of the constellation called Orion. Here's Orion's belt. Of course, you would see the great nebula of Orion would be right about there. And then if you also take a look with a telescope right here would be the Horsehead Nebula and so forth. Well, that's for another story. But again, how big does the constellation look? When you go out there and you finally see it, you go, wow, look how big it looks. But how do you put a measure to that? Again, what you can do is you can go ahead and draw lines like this and like that, and you see that this would be roughly an angular size of about 5 degrees. If we take the whole constellation, which goes up like that, and then another part of the constellation. So Orion actually is a little bit bigger if you take all of the stars into account in the constellation. But if you just take it this part that most everybody recognizes, that makes an angular size of about 5 degrees. That gives you kind of a feel of how big things are. So what we have to keep in mind with astronomy and angle measurements is that, of course, if you have a small circle here, and you make an angle theta this big, you can see that on the edge of the circle it makes for an arc length about that size. But if the circle is bigger, so the edge of the circle is farther away, for the same angle you have a much longer arc length along the circle. And you can see, so two different objects of different size can have the same angular measure depending upon where they're located. So in astronomy, it's easy to measure angle. And so the way we measure angles is, of course, we can say that if you go all the way around the circle, that would be a 360-degree angle. If you go a quarter circle, like this, that's called a 90-degree angle. So typically in astronomy, we're looking at things that are much smaller than 90 degrees, a few degrees or a fraction of a degree. Matter of fact, in astronomy, most things are so small because they're so far away. Not that they are small, but they appear to us, they appear as very small because they're enormous distances. We tend to think of size in terms of less than a degree. So let's talk about that. So we have, of course, 1 degree. That's equal to 1/360 of a circle. So 1 degree angle is typically a very, very tiny angle. So imagine that there's 360 degrees in a circle. So a 1 degree angle is just a very small angle relative to the size of an entire circle like that. But since in astronomy even a 1 degree angle is quite a large angle, notice that the moon is only 1/2 degree in angular size, and so is the sun, and stars, of course, far away are much smaller than that. We have smaller angular sizes. For example, we have what we call 1 arc minute, which is equal to 1 with a single dash around it like that, which is equal to 1/60th of a degree. So there are 60 arc minutes in 1 degree. Imagine a small angular slice like this and chopping it up into 60 equal angles, and each one of those tiny little slices would be 1 arc minute. And then we have even smaller angular size that we use in astronomy. We call it 1 arc second. And notice that is equal to 1/60th, or maybe I'll write it like this first. First of all, the notation would be 1 with 2 double dashes like that. And so this is equal to 1/60th of an arc minute, which is 1/60th of an arc minute. So that's just a notation. I'll just write it out so you can see that. Which, since there's 60 arc minutes in a degree, this is equal to 1/3600 of 1 degree. I don't know if that makes sense to you when I write it like this, so maybe I'll write it like that again, 1/3600 of a degree. Okay, this little circle right here up there, that simply is the degree symbol. So when you see that, 1 degree, that means 1 degree, or we can write out 1 degree or 1/3600 of a degree like that. So an arc second is a tiny little sliver of an angle. And yes, in a lot of cases we use arc seconds because things in astronomy are so far away and they tend to be so tiny, only very powerful telescopes can see them, that we need to use those very small angular measurements. So an arc second is a common measurement in astronomy. Matter of fact, most stars have a diameter, an angular diameter of an arc second or even less. That's how tiny they are. That's why they look at little points of light, even though they're spheres. And then larger things in astronomy, such as nebulas and planets that are a little bit nearby and so forth, well, they have a slightly larger angular measurement, of course, than the moon, the sun, and large constellations. They have much larger angular measurement, which can typically be measured in terms of a fraction of a degree or several degrees in size. So now you have an idea. If someone says, oh, look at that star is 0.5 arc seconds in angular size, you know you're looking for a very tiny dot in the sky. And that's how we use angular measurement.